Hey everyone, and welcome. So today, we're going to pull back the curtain on something pretty fascinating, how a large language model is actually built. We're talking about the whole journey, right? From the raw, chaotic mess of internet data all the way to a powerful, thinking machine. Ready? Let's dive in.
I mean, think about it. We're asking LLMs questions all the time, right? To write an email, help us with some code, maybe even whip up a poem. But have you ever stopped to wonder what's really going on under the hood? Like, how do you even start? How do you go from just nothing, a blank slate, to something that can tackle pretty much any question you throw at it? Well, that's exactly what we're going to unpack.
It's so easy to picture these AIs as these, magical floating brains in a sci-fi movie. But the truth? It's way more down to earth. That AI brain you see on the left, it's built entirely from the stuff on the right. We're talking about massive, sprawling, totally unfiltered data that's been scraped from the web by projects like Common Crawl. So, no, it's not magic. It's actually a pretty monumental engineering challenge.
Okay, so here's our game plan for today. We'll kick things off with a pretty cool analogy for LLMs. Then, we'll get our hands dirty, turning raw data into high-octane fuel. We'll even jump into the big debate on how to train these things, give them a little memory boost, and then finally, launch them out into the world. And to wrap it all up, we'll focus on the one ingredient that really shapes their future.
All right, so to really wrap our heads around this whole thing, let's use an analogy. I want you to imagine building an LLM is like being a chef who's trying to create a world-class, gourmet meal completely from scratch. And where does any great meal begin? Well, it all starts with the ingredients. So, here we are in our 5-star AI kitchen. And what's the first rule? Prep your ingredients. In the world of LLMs, there's really only one ingredient: data. And we're talking just massive, unbelievable amounts of it. But here's the catch. Just like a real chef, you can't just dump everything you find in the pot and hope for the best.
So our whole journey kicks off right here with something called Common Crawl. What is it? Basically, it's a snapshot of a huge chunk of the public internet. The scale is just mind-boggling. We're talking trillions of words from blogs, news articles, forums, you name it, it's in there. This is our raw produce, fresh from the farm, or, fresh from the web.
And when we say raw data, we really mean raw. Just look at this. This is what it looks like. It's not nice, clean paragraphs. It's a complete jumble. You've got chunks of academic papers written in LaTeX, that's a system for scientific papers, all mixed in with website code, random forum comments, everything and anything. It is messy, really messy.
So how on earth do you turn that mess into a gourmet ingredient? Well, you've got to clean it. You run it through a super rigorous process, something like this refined web pipeline. It's like a multi-stage filter for the internet. First, you get rid of bad URLs. Then you pull out just the text. Filter for the right language, and this next part is critical. You get rid of all the duplicates. Every single one of these steps is absolutely essential. It's just like washing, peeling, and chopping your vegetables before you even think about turning on the stove. Now, this is a really clever part of that cleaning process. When we talk about getting rid of duplicates, or deduplication, it's not just about finding text that's copied and pasted. Nope. Something called semantic deduplication actually understands the meaning of the sentences. It does this by looking at their mathematical representations, which are called embeddings. It can then find and remove stuff that basically says the same thing, even if the words are totally different. Why do this? It stops the model from getting biased by the same idea over and over again, and it makes our final dish way, way better.
Okay, our ingredients are all prepped, they're clean, and they are ready to go. So now it's time for the main event, the cooking. This is the training phase. This is where we take all that pristine data and use it to teach our model all the patterns and nuances of human language. And right here, this is where developers have to make a really big choice.
And that choice is basically this. Do you build your own professional-grade kitchen from the ground up, or do you rent a high-end, state-of-the-art one where everything's already set up for you? On one hand, you have something like AWS EC2 with raw GPU power. That's like building it all yourself. You get total control, which is great, but you're also responsible for literally everything. On the other hand, you've got a managed service like Amazon SageMaker. It handles all the complicated setup for you, so you can just focus on the cooking.
And here's the argument for building your own kitchen. This Reddit user puts it perfectly. We mainly need the computing power, GPU, and nothing more. See, for them, it's all about the raw power of the stove, the GPU. They've got the skills to handle all the plumbing and wiring themselves. And what they really want is that super fine-grained control you get when you do it all yourself.
But then, you've got the complete opposite view. As this other user says, trust me, Any half-decent company understands the benefits of managed services and doesn't try to recreate the wheel. Their point is, why are you spending all your time on the plumbing when you're supposed to be a 5-star chef? Let a managed service like SageMaker handle all that tedious but absolutely crucial stuff, security patches, scaling, monitoring, so you can just focus on what you're actually good at, cooking up a great model.
So our meal is cooked. The model is trained on a gigantic dataset. But there's a problem. What happens if some big news breaks tomorrow? The model has no idea, right? Its knowledge is frozen in time. This is where we need to add a special sauce, a technique that gives our model a kind of real-time supermemory.
That special sauce is called Retrieval Augmented Generation, or just RAG for short. And honestly, it's a total game changer. Here's how it works. Instead of only using the knowledge that was baked into it during training, a RAG system can go out, pull in fresh, relevant info from some external source in real time, and use that to build its answer. This is so important for keeping the AI up to date and, frankly, for fighting against hallucinations and misinformation.
So how do you build that external knowledge source? Well, surprise, surprise, it's another pipeline. First, you load in your new data, say a bunch of recent articles. Then, you split them up into smaller, more manageable chunks. And finally, you store all those chunks in a special kind of database called a vector database. The cool thing about it is that it's organized by meaning, which makes it super fast to find the exact piece of information you need for any given question.
And just to make that idea of splitting a little more real, check this out. In one example from a LangChain tutorial, a single blog post, just one, was broken down into 66 smaller chunks. 66! Why do that? Well, it lets the RAG system be super precise. It can find and grab just the 1 or 2 paragraphs that are most relevant to your question, instead of having to stuff the entire article into the model's brain.
Okay, our gourmet meal is cooked. We've added our secret sauce that gives it a perfect memory. What's left? The final step, of course, plating it beautifully and serving it to our customers, who, in this case, are the end users. This is what we call the deployment phase. So what is deployment? It's really all about taking this incredibly complex model that we've spent all this time building and packaging it up so that anyone can use it easily. You do that by creating something called an API endpoint. You can just think of it as the simple ordering window for our super complex kitchen. A user sends their question to the window, and the system just sends an answer right back, hiding all that crazy complexity behind the scenes. And of course, this final step doesn't happen in a vacuum. It's supported by a whole ecosystem of really powerful tools. You've got platforms like Amazon's SageMaker, which we've talked about, but also Google's Vertex AI, Databricks, and others. These are the tools that provide the heavy-duty infrastructure you absolutely need to serve an AI model at scale to, potentially, millions of users.
And this whole toolkit is used to serve up a huge variety of different models. It's kind of fun to remember that the AI world isn't just one big thing. It's filled with all these specialized projects, and they each have their own focus and, well, their own personality. You've got Stanford's Alpaca, the coding-focused octopus. It's a really vibrant community of people building all these incredible tools.
Wow, we've been on quite a journey here, haven't we? All the way from that messy, raw data to a fully deployed AI. But if there is one single thing I want you to take away from all this, one theme that connects every single step we've talked about, it's the incredible importance of that very first ingredient.
This quote from a big academic survey just says it all perfectly. The performance enhancement of models is closely tied to the use of high-quality datasets. Think about it in terms of our analogy. You can have the best chefs in the world and the most expensive kitchen on the planet, but at the end of the day, your meal is only ever going to be as good as the ingredients you started with. For LLMs, it really is that simple. Better data equals a better model, period.
And that really leaves us with one last question to chew on. If AI is this gourmet meal that's cooked from data, and if we're all just now figuring out the best ways to source, clean, and prepare that data, what incredible new creations are going to be possible in the future? What amazing new capabilities are we going to unlock once we truly master the art of finding those perfect ingredients? It's a pretty exciting thing to think about. Thanks for joining me on this journey.